Hello, hello. Good evening. Good evening. Happy Sunday. I hope that everyone is having a blessed and beautiful evening. Thank you so much for joining again. Right, y'all. So just a moment ago, one of my accountability partners just made me pause, right, and really realize like you've been making sure to be consistent with your math mindset reset. We've gone live every Sunday or every week because we made that slight adjustment, right, for Super Bowl Sunday, but we've been live every week for this year so far. And listen, this is the last Sunday in February, so we are 2 months solid. That is a win we are celebrating this evening. So thank you so much for those of you all that are tuning in. Y'all, to be super clear, we're talking about why math instruction has to be more than numbers, why it has to be more than just that, right? We do know that math is everywhere. Math is everywhere, but too often students really experience it as disconnected, right? The numbers, formulas, that's just something that maybe they understand, they might memorize it, but there's no connection that they can apply it and maybe even enjoy it. So we're talking about that. We're diving into why math instruction has to be more than just numbers and what it means to build confidence, critical thinking, and those real world connections in math class and at home. You all, if you've ever heard a student say, you've ever heard your student, right? Maybe you're a young person or young people at home say, well, I'm just not a math person, right? If you ever heard that, drop any number you want to. Drop your favorite number in the comments. If you've ever heard, right, you overheard a young person, maybe your specific young people say that, I'm just not a math person. Y'all, please drop your number, whatever number you'd like in the chat. So what we were talking about, again, sometimes there's too often that disconnect between the numbers and formulas and how to understand and apply it and maybe even enjoy it. So think about this. How often as adults does someone really realize, you know what? So those percentages they were trying to teach us about, percentages, mental math, no one ever told me how much I would need to calculate maybe sales, tips, and discounts in my head, right? Let me know if you can relate. Maybe as an adult, right? These are just some conversations. Someone said, I use ratios and proportions, right? Every time I adjust a recipe when I'm cooking. So I wish we had kind of practiced math through that lens, those more real life applications. Let me know if that resonates with you. So budgeting, I mean, hello, right? If we're not talking about finances every day, if not every other day, right? In a lot of spaces. So budgeting, people said, oh my gosh, I had no idea how crucial just those basic algebra and basic percentage knowledge would be when managing finances, calculating interest rates. You all, these real world applications, too often, again, there's a disconnect. So, time management and scheduling. So, in elementary school, we do start to learn and cover elapsed time, speed, distance, right? That some people said, you know what, it's been way more useful than I ever thought, right? They said, I was that person asking, when are we ever going to use this? But it's only because the clear connection, the clear relationship had not been made for those things. Okay. So, kind of being funny, but kind of not. You all send this to someone, text someone that, maybe sometimes they struggle a little bit figuring out the tip at the restaurant. You know, Tag them, send it to them. Because we're talking about, again, the connections and the relevancy, right? So, why math has to be more than just numbers? Generally, there's a history to math like everything else. So generally, traditionally, math instruction has fallen short because we've treated math for years. We've treated math that it's only about numbers and formulas. But when we do that, y'all, we strip it of the meaning. We strip it of its context, which is not only useful but engaging. So traditional math instruction often fails to connect the what with the why. Right, we talked about that before. So there's a disconnect for the what with the why. People know what to do, have no idea why they're doing it, nor the when. So a lot of the context, gets lost as well. And that's where true breakdown is happening. True breakdown happens. So, why memorization is not mastery? We talked and did some blog posts and some other content about why we can't do and just lock in only on rote memorization. But if at this point in society and young people's math lives, we need them to master a concept, not just be able to recall the formula, recall the math fact, that's not the same. That's not even the same level of awareness, the same level of cognition, right? With just your being able to truly apply it, the depth of your understanding. So memorization is not mastery because too often students are taught math as disconnected rules and procedures. Right? To change your fraction to a decimal, do this. To change your decimal to a percentage, do this. Versus all those concepts being wrapped into a real world problem, a real world scenario. So students might memorize, we'll talk about this a lot, they might memorize these multiplication tables, these algebraic formulas, or geometry proofs without ever understanding why they work, when they're supposed to use it, right? So many students might remember, so there's this thing for trigonometry. They say SOHCAHTOA, and it's basically just talking about the different ratios that students are supposed to remember as part of trig, right? So that the sine, the cosine, and the tangent, just the ratio that they set up, but without any kind of context that, okay, we'll really use that and it's useful. Trigonometry is useful in construction, in physics, and in your computer graphics. And think about how many students like to be are interested in being gamers. They're interested in being just so many different in so many different areas and spaces, right? The interior designers, when all of that is spatial reasoning, right? So in trig, someone said I lost them at trig. So just stay with me because you know about interior design, you know about gaming, right? You know about construction. So whether or not that has been made plain, that connection has been made, like for me, that's always a big deal. Like you all, so we call it, sometimes we hype it up, and we're going to talk about that. Sometimes educators, I feel like, hype up the math, right? We have the wizard complex, right? The Wizard of Oz is really not that serious. It's a person behind a sheet, but we've hyped it up so much that it comes with its own set of disconnects, anxieties, etc., when we really should be working to make it as plain and connected as possible, to me. All right, here we go. Y'all, we're rolling today. We're rolling. So, and you know what? And I'm so glad. So, this person, someone you're going to know, I'm talking to you. So, when we take the context, when we take the context away from math, if we're only teaching math through pure memorization, it's like someone teaching the steps to a dance, but never letting them hear the music. They might get the movements right. They might nail the movements, but they never feel the rhythm because they never heard it. That's the difference. That's what application is. Can you imagine learning a dance, but you never, right? You never heard, you never caught the rhythm because you never heard the song. My goodness. My goodness. I'll say that. Y'all, so let's be real. Let's talk about it. What is something that you memorized in math, right? They live rent free. You remember to this day. What's something that you memorized from math, but you never really understood what was going on? Y'all talk to me. What is something that you memorized from math, but you never fully understood what was going on, but you can recite, right? Okay, someone said integers. Now, if I say Pythagorean theorem, I bet y'all can give me the formula. A lot of people still remember that, right? A squared plus B squared equals C squared. Yeah. So think, y'all, what is something that you had to memorize but never fully understood? Some people say the quadratic formula. Listen, I was a quadratic formula writing professional because I remember that my 11th grade teacher, she used to sing it to us. So it was catchy, right? I'm a music girl. She called me with the music, but I had to later learn more context, right? For when we could apply that concept. Y'all, what else? What else? Sometimes probability, right? Probability, like, okay, well, how often am I gonna, how often am I gonna be rolling this number cube, rolling this die, people say, right? However, think about you all, to an extent, to an extent, going to the doctor, right? Probably running these blood tests, more than likely, this is what's going on based on these criteria, right? Slash decision making, general risk. Y'all know that's how we pay insurance. They're calculating probabilities behind the scene, whether it's health insurance, car insurance, their house, right, home insurance. They're calculating probabilities behind the scene the whole time, right? Weather phenomena. Okay, someone said E equals MC squared. Yes, right. So formulas, that's something we memorize the formula, but did we have a solid grasp or a clear understanding and foundation on what was really going on, what it connected to? All right, y'all. Thank y'all. Thank y'all for sharing with me. So the next thing we're talking about, if we said memorization is not the same as mastery, so let's talk about some things that are happening. We're talking about confidence versus a competence gap. We already said math anxiety is real. Y'all hear us talk about that a lot. A lot of you all can co-sign yourselves. Math anxiety is real. 93%, a study found that 93% of US adults experience some level of math anxiety. And let's be clear, y'all, again, it didn't start when they hit adulthood. Most of the time when they rewind, they've asked those adults to elaborate, and it did occur, right? They started feeling anxious about math in elementary. Y'all, there's another stat that says it's about 60% of people, it starts in first grade as early. Y'all, you're six and you have already learned and internalized and applied anxiety to this situation, right? Someone said fourth grade for me. They said definitely, y'all. It starts in elementary. So for those 93% of adults, for most, it starts in elementary. So when we're talking about anxiety, anxiety is a disruptor. Let's be super clear. It disrupts your working memory and it's harder for students to engage with problem solving. So let's really talk about what that means. If it disrupts your working memory, so somewhat the memorization, I'm already a bit lost. Now I'm a little bit lost in the sauce because I was supposed to remember something and now my anxiety is acting up and everything is kind of gone. That happens. That's real. So it's that much harder to really go through the steps and layers of problem solving if kind of level one stuff isn't functioning properly, right? All things are not firing. All cylinders aren't firing how they should because the anxiety is disrupting that. When students also believe that they're not math people, they disengage. They disengage. Y'all, that's one of the most joyous things for me talking with adults who sometimes are like, oh, no, I can't math, right? I don't know how to do that. And then I'm like, well, have you, and I give them a real world situation. Well, have you ever? And they're like, yeah, all you had to do was, I'm like, well, yeah, you were doing fractions then, right? You were really doing algebra, but maybe they didn't say it that way. And it's just these light bulbs and this clarity. And that's always the goal. Yo, that should be the goal regularly. Light bulbs and clarity. That should be it. Okay, someone said they couple that with undiagnosed ADHD and general anxiety. Yeah, some struggles for sure. For sure. All it did was compound that, for sure. So, besides anxiety, how much emphasis, and let's be real about it, how much emphasis is put on the correct answer? For a lot of people, it's a learned obsession. It's a learned, well, did I get it right? What's your answer? What'd you get? Right? It's a taught and learned obsession if we're not careful. So many students think that math, the end all be all for math, is about getting the right answer fast, about getting it quickly, instead of understanding the process of thinking through a problem. So this is also why when A student might work a question and you're like, okay, how did you do it? They're like, well, I don't know. Is it right? And they don't even want to engage. They don't even want to entertain the idea of trying to walk you through their reasoning, walk you through their strategy, because they're just like, listen, ma'am, is it correct or not? Because that's what they've learned. Whether it was said directly or not, that's what they've learned along the way. That's what they've learned. So for a student that might see 5 times 12 simply as a multiplication question, rather than if they've seen it presented as an array, right? Where you have your rows and your columns. If they see it as part of a pattern or part of a real world budgeting scenario, right? We're talking about 12, so maybe something was happening monthly. All these types of opportunities, right? If we aren't showing all these different layers, these different perspectives, then we're missing the chance. They're missing the chance to build that conceptual understanding. Again, they're dancing without the song. They're dancing without the song. Okay. Yeah, very procedural versus conceptual. And again, the reality is most of the questions that these young people are going to interact with on paper in the classroom and in real life, y'all, that is it's conceptual. You have to understand it deeply, really and truly. Okay. So what is a math mistake that you made in your life? If you're a math educator, tap in, you or maybe your students. And as you work through it, as you unlearned that mistake, it helped you deeper in your understanding of the concept. Okay, so what's a math mistake that maybe you made or a student made that actually helped you to understand the concept better? It helped you to understand the concept more deeply, right? I know last week I talked about order of operations for me, right? How at first, very literal in my understanding of PEMDAS, like, all right, well, I'm going to multiply, then divide, then add and subtract. And we know that that's not always the case. It's not always multiply before divide. It's not always add before subtract. Okay. So just someone said, understanding regrouping better, right, with second graders because of understanding expanded form. That's powerful. A lot of people skip that step. And I will say, looking back as a math educator, I don't really remember learning expanded form. I know I learned it to teach, right? Young people, but I don't remember learning expanded form myself. And so think of, just like someone said, they understand regrouping now, what's really happening. Think of the connections, and the young people see it sooner. They see it more clearly. Okay, a few people regrouping. So also to a point where a lot of the times when people are actually adding or subtracting, even if they didn't learn regrouping, if they're doing it mentally, right, if they're performing the problem, they're answering the question mentally, guess what? You regroup anyway. Tell me the truth. You're like, all right, 28 is two away from 30. And then tell me the truth. You regroup. And a lot of people, when they do it mentally, they regroup anyway. So again, when we talk about the new math, it's just some things that were kind of embedded and happening behind the scenes that we're making super clear, being very explicit about with these newer generations. That's all. So someone said the relationships between number families. Can you say a bit more about what you mean? You mean like your multiplication and division facts? Or you mean the place values, how they're increasing by 10, like a 10x? What do you mean? Okay, but thank you all so much. So for this, yeah, when we get into geometry though, geometry can be tricky. It can be a little bit of a bear sometimes, right? Especially when you get into those questions that are like, well, a rectangle wasn't a square, but a square was right, that kind of a thing. But just being clear on what the definitions are, right? Because it gets down to the nitty gritty, right? How all rhombuses are squares, but not all squares are rhombuses, and what are all the family members in the quadrilateral family. This is maybe like this is upper elementary getting into middle school with some of those things. But again, That was something, right? When I looked at the question years ago, I was like, a rectangle is not a square. What the world, right? I really had to take my time with it and back up because someone said that geometry was their favorite and they really have amazing spatial awareness. But not Mrs. Jones at first or Miss Seals at that time did not. So I had to develop it. I did. That was probably like we talk about those four areas for math. That was my least. That was my least strongest for sure. Radius and diameter was everything. Yes, and we have a book that talks about that really helps to secure that vocabulary. So we're going to be doing a book special soon with some math books. Yes, we should and would read in math class. So talking about that for sure. You all, besides that, sometimes the negative signs in algebra. And I'll say this, a lot of you all know that I do some contracting. So I still work with some young people directly daily. And so, again, the hype up, this wizard complex, especially comes up when we talk about algebra. I don't know how early it starts exactly. I don't know if it's when they are like, all right, we're going to learn algebra. If the kids are like, what is this? But, the reality is these young people have been doing algebra since they were in pre-K. Since they were in pre-K. Remember, at first, it was just a blank. Blank plus 3 equals 6. How do you figure out what goes in the blank? Oh, I just subtract. Hold that thought. When you got a little bit older, then the blank became a box. The box times 2 equals 12. How do you figure out what goes in the box? Okay, I just divide. I think about the fact families. Bet. Hold that thought. So then it becomes a letter. There's just a progression, but somewhere, right? The students are like, oh, why we have letters? Why do we have letters in math class now? And it throws them. But imagine the power. We talked about relationships and the connections. Rewind that tape back for them. Yeah, as soon as they see it, yeah, the confidence. We're talking about confidence to help build that competence gap. We have to build up the confidence, and that's a great way. Rewinding the tape, helping them make the connections. I can't stress that enough. Cannot stress that enough. Someone said, it's just the wording, math terminology that trips a lot of people up. Most people don't realize they're doing strategies even when doing mental math. Yes. And that's why we have to say it all the ways, right? We say it using our official terminology, our academic vocabulary, but making sure they understand what it means, but recognize it when they see it. We have to. That has to be part of the job that we do that. We have to. Someone said, then it became a letter. That was me. Listen, all the children sit there like, nope, I thought this was math. We add, subtract, multiply, divide. This lady just put a letter on the board. Nope. But, we don't leave them there. Rewind it, we rewind the tape and run it back. Definitely. All right. Y'all, listen. So in these moments where I appreciate y'all being transparent about some areas, right? Where, like it wasn't until I made the mistake, but it helped deepen my knowledge. Speaking of mistakes, they're going to happen. They're necessary. How do you handle them? How do you handle mistakes, especially in math class? Are you a person that corrects them quickly? Does it become a teachable moment? What? How does it go? How does it go? Is it part of your culture that we're going to make some mistakes? What happens? How does that go? Okay, so someone said identify them at the point of error. You all, what if I told you? Y'all gonna be like, what? Right? Someone said the exact error. What if I told you that sometimes I make mistakes on purpose? Because Emmanuel, we talked about those kids that part of their takeaway was, oh my gosh, is the answer correct? Did I get the right answer? Miss, is it right? Yes or no? Then I purposely make mistakes sometimes. To go back and be like, oh, y'all, excuse me, I made a mistake. Let's go back and fix this. Let's go back and see. Slash, right? I hear a lot of people saying a teachable moment, learning opportunity. Yes, feigning ignorance. Yeah, teachers are great actors and actresses. Oh, yes. Okay. But definitely addressing it. Sometimes that's the whole lesson. All right, there's some work done. Some of these are correct, some are not. We're looking at errors. We're looking at errors. Y'all know how I feel about error analysis. I keep talking about it. It's really, there's so much to say though. That's going to be its own webinar soon because there's so much to say for error analysis and different ways to do it. But quick moment, right? Definitely making mistakes yourself, identifying the mistake right then and letting them know, look, okay, you know what, this is a common mistake. There's even a math strategy called my favorite no. Like, no, that's not correct, but it's my favorite no. Let's talk about why. And it's usually a conceptual thing. Someone earlier talked about conceptual versus procedural. It's usually a conceptual thing. But we talk about it. We flesh that out. We talk about it. So the missing pieces, y'all understand that in our work, we're taking math meets SEL and meets inquiry, just those questions, building that curiosity, and also leveraging AI. That's where we are in our work at Holistic Fluency. So, math again needs to be more than just procedures, it needs to build reasoning, resilience, real world connections. Math challenges really require some grit, some perseverance, and some self reflection. Too many of these things, if we're not careful, right? Because that's more of the SEL where people say, oh, no, we don't have, no, you have time. You want to make time because, again, even if we're talking numbers, statistics, when SEL is implemented and embedded in math class, it's double digits for the percents and increase in student achievement. Okay. It's not just, oh, we're just doing something to do it. It builds that grit, it builds that connectedness. The children learn to look for connections and relationships, right? And their self reflection. So we talked about the error analysis and the teachable moments. They get there themselves with practice. Students learning to self regulate their frustration and reframe mistakes. Not only are they learning opportunities, it's going to happen because I tried. We're going to make mistakes because we're learning. You make mistakes along the way. Y'all, there's so much difference in that conversation than, oh, you got it wrong. Let's see what you did. There's a huge difference in the conversation, and as a result, the culture of the classroom and the culture of the work and levels of achievement that the students even hold themselves to at that point. Okay. When we talk about the inquiry based, listen, any student, any child I've ever worked with, maybe even to this day, right? Even my 28-year-olds, they probably can tell you what my favorite question is, my favorite word. Why? Now, you know how it's almost a joke how maybe 2-year-olds would just ask that incessantly. Well, why? You answer them. Well, why? And you answer them. And why? And they just keep going till you're finally like, okay. But we do need to ask that, right? We do need to ask why. Well, well, Mrs. Jones, I got 10. Okay, well, tell me why. Tell me, how did you get that? What strategy did you use? So again, students should be explaining their reasoning, not just solving the problems, right? Not just what's the answer, but why does this equation make sense? Why is this answer reasonable? Right? How could it change if it was just one number that was different? If I put the parentheses around this operation group. Yeah, so much power in the reflection. So reflection, someone said the glows and grows, right? Positive interaction. I love how you organized your work on your paper. I notice you use the incorrect operation here, right? Okay, let's talk about that for a minute. Use the incorrect operation here. One thing students have to get used to, again, we're doing the interdisciplinary, we're connecting and being more consistent across content. So if a child chooses an operation, I need you to tell me what word in that problem, what word or phrase told you to choose that. Because we're not freestyling. Freestyling is for the pool, it's for the studio, not math class. So what made you choose that? What's your proof? Right? In reading, we call it annotating, we call it providing our evidence. We need receipts in math class also. We need some proof. So what is it from the question? What is it from the question that said, okay, this was a good operation to choose? Right. And have them talking about it. Have them talking about it. So we're talking a little bit more again about AI. AI as a support, not as a shortcut, as a tool, not a crutch, right? Not the end all be all. So if we use it correctly, instead of just using AI for quick solutions for the answers, y'all gonna forever hear us say this, explaining the concepts in multiple ways. We know that that's always one of the goals in the math class, right? Well, making sure the students can understand this scenario different ways. Like for example, area. We like to talk about, well, when will we see area in the real world, in real life? Well, we're painting a wall, right? Maybe I'm doing something, I'm getting the little popcorn, what's it called? The popcorn stuff on the ceiling, popcorn ceiling. Maybe I'm putting some tiles down but it's making sure they understand that they're covering a space, right? When they see the word cover in the kind of question. So all of these things, again, helping them make these connections. But if we're having AI show them multiple ways, y'all, that's going to help them deepen their understanding. So maybe it's an area question. Maybe it shows using the formula. Maybe it's showing using the square units, actually, like the overlapping of the grid on top of that shape. The more ways, the more exposure, their concepts are just deepening. They're deepening their understanding. So think about it this way. Y'all know I like analogies. We talked about the dancing, right? Dancing earlier. Um, if AI is used for thinking, let's think about it like a GPS. So we're helping guide students through the problem solving, not just dropping them off, right? It's a way that they can see their plan and get there. They're still going to get there, but they have some control, and their participation is more active if we're acting as a GPS versus just dropping them off versus being a chauffeur. All right, y'all, let me know what y'all think about that one. Y'all know I like some analogies around here. Okay. So, still thinking, I want you all to continue to reflect on some of your personal math experiences, whether it's with students or you as little you in class. What was something that you wish had been done differently for you in class? Some of y'all talked about it, but during math class, what is something that you wish, I wish they had done more of, I wish it had been different in this area, right? Do you have a resource about prompting AI for math or something like that? Yes, we're going to talk about it in a minute. We sure do. Yes, definitely. Hacks and prompts for math educators for AI. Sure do. So someone said, I wish my teacher spent more time helping me understand the concept. What do you mean? Can you say more? I was like, we've talked some on some of our chats and our talks about the 3 phases of math. So where we actually have to touch it, we call it the concrete phase, right? You have to touch it, use some kind of manipulative. And the manipulative, we said it could literally be the top of a desktop sometimes, right? Then we have a representation where we're drawing the picture, and then we move to solving problems. So just along the way, you're building your understanding, your depth is increasing the whole time. So the real world application, someone said, yes, yes, because again, if we want people to be out here and be problem solvers, critical thinkers, we need to give them these multiple exposures, these multiple experiences. They need to understand. So, okay, to a point, we talked about Pythagorean theorem earlier when I said, okay, what are some things that we memorized? A squared plus B squared equals C squared. So some of the ways children will understand it, or they might see it in a word problem, a real world problem, is that, okay, in order for you to get to school, you have to walk, you know, 3 blocks east and 2 blocks north, something like that. But there's also a park that is on a diagonal from the school to your house. Yeah, it made the right triangle. That's the Pythagorean theorem. If they solve that, they'll know how long what is the length of that shortcut through the park. That's the kind of questions, real world things. But think about that. People that catch the bus, people that walk to school or walk home, that's in their sphere all day, but they just never had that connection made, perhaps. Okay. So often, as someone said, math felt too abstract because people, yeah, I get upset. There's only 3 steps. There's 3 steps in math instruction, but people skip 1/1.5 all the time. So for many people, that's exactly, I appreciate their honesty. That's exactly how people felt and feel, like it was just something kind of on the paper out there versus these day-to-day realistic connections between these different concepts. Okay. Y'all, I just want to be so clear that at Holistic Fluency, we believe math is about more than just numbers. So we're developing thinkers, problem solvers, and confident learners, right? That's how we approach it differently. So it's not just about equations, it's about thinking. So instead of just solving for X in the equation, okay, so what is 3x plus 5 equals 20? Students will explain how they solved it. They can compare different strategies, different ways to solution it. They can apply it to a real world budgeting problem, multiple ways. You all tap in when and if you've seen a student truly light up about a math concept. How did you know? And what made the difference? Like when you saw like that light bulb go off and it was connected to a math concept, what do you think made the difference? Okay. So one thing for me, and I talked about it already, a lot of times it clicked. It clicked for me that I set the tone as the teacher in how I approached the problem, how I approached math. And that was shape and kind of manage their expectations, right? I had students write notes. For some, it was as simple as you smiled, right? I never had a math teacher smile, right? Y'all know generally I'm pretty smiley. So when we really realized, that, okay, the way that I approach this, again, I talked about like the wizard complex. If I'm hyping it up, then they're gonna get, even if they weren't anxious about math, they'll develop a math anxiety around this one lesson because I was like, all right, y'all, here we go. This one is really hard. You're gonna have to lie. So all of that kind of approach and thinking that shapes and manages their expectations. And so as parents, as educators, we have to be super mindful about that, extremely mindful about that. Someone said, I enjoy PBL as a teacher. I think those hands on activities would have helped. Yes, they should be done across the board, realistically. Yes, yes. Middle, high school teachers sometimes forget that listen, that's this whole own thing. And we have a resource coming out just for that, connecting the manipulatives to use like for certain concepts, like for to help to build number sense, still getting more into geometry, and then also for algebraic thinking. Even though they're bigger kids, they're medium to big kids now, right? Yes, we still can't skip these phases of the math learning. So definitely still going through concrete, through representation, and then abstract. Being able to use manipulatives. Yes, like that's literally where everyone is supposed to start. And it shouldn't be exclusive, to a certain group of students or not. Like this is how we learn math, y'all. That's it. 3 steps. We have to do all 3. Not 1.5, not 1. So while we're building these problem solvers, we want them to be persistent, right? We want them to, yes, express their uncertainty, but not stay stuck there. I'm not sure, Mrs. Jones, but I think, and still share their reasoning. Okay, but I do know this one, Ms. Jones, because, and also helping them to ask clarifying questions, right? So even if they're asking you back, right, that's always the ultimate test when your kids do to you what you do to them, right? Well, can you explain to me how you did that? Can you explain your reasoning, please, Ms. Jones? Right? So that's the goal, honestly. And sometimes that's hard, but that's the goal. Someone said that's so true. The teacher should be the hype man. Yes, yes, yes. So we talked about when students are frustrated and we're helping them push through. A lot of you are already chimed in. You said you make sure that they understand that that's part of the learning process. You encourage them to press on, to not stay stuck there, right? Sometimes you might take a brain break, right? Sometimes stepping away gives your brain that fresh moment, the fresh juice that it needs to reapproach the situation. Sometimes we have think alouds where you model your own thinking, right? If they don't ask, if they're not there yet, so Mrs. Jones, how did you? If they aren't there yet, then yeah, they might model their own, we might model our own thinking out loud. Because again, what's wrong with them seeing the teacher make the mistake? Are we still in wizard mode? Right? Even if it's an orchestrated and a fabricated mistake. Let them see it. Let them see it. So one time, I'll say this though. One time I messed up, and a student had to come back for a part of a period. Like something happened, right? They called the first part of their period. Maybe got called to the office, so they came back during an elective. They asked, right? Because that's a no-no. But they asked could they come back to finish getting their notes. And he almost outed me. He said, Miss Jones, you made that same mistake in that same spot. I said, oh, wait a minute, security, wait a minute, right? But that was the whole point that day. Like I had a planned mistake for every period that day, truly. Right. But he almost gave me up. I said, wait a minute. So while we're talking about, again, leveraging AI for your deep thinking, y'all, so many stories. Y'all know I have stories for days. That AI can be the coach, not a crutch. And we want to make sure we're just kind of wrapping it all up. We're generating multiple solutions to the same problem. I say this all the time. I'm like, y'all, math should be much more flexible than people kind of approach it as. Because if we're super clear that 1 + 3 = 4, that 2 + 2 = 4, and also that -3 + 7 = 4, then why are we not approaching literally the problems that same way, right? The strategies for solving the problems. We have a lot of ways to get there, but people aren't doing that. So one thing I want to do is talk to you about our webinar that's coming up, right? I'm going to drop the link. It's also in our bio link. And we're focusing on questions to mastery, promoting critical thinking in math with AI support, you all. We're going even deeper, especially in our questioning, our reasoning, and how AI can transform the way that we're teaching and learning math. So make sure that you click that bio link and you pull up soon, okay? And I'll drop it here in just a bit. And it's always at this same time. We do our webinars on Sundays during that same time, but they're a little longer, right? Y'all, please let me know in the chat, what is your biggest takeaway from today? What's your biggest takeaway from this evening's live? I'll wait. I'll give some teacher wait time. What is your biggest takeaway from this evening's live? And also, what someone asked about, we do have our AI powered assessment toolkit that is launching in these next couple of weeks. So again, if you have not registered for the webinar, if you are not on our email list, those are some things you want to do. Those are some things you want to do with ourselves very soon so that we can be kept in the loop on all of these things. So this AI powered assessment toolkit, again, it's not just prompts, it's prompt specific to math class, specific to math outcomes, right? Especially when we're thinking about error analysis, conceptual versus procedural, what other kind of errors are there, right? We really get into a lot. There's a lot of analysis, right? That's the best way I can think to say it. There's a lot of analysis around the errors and how AI can help make that even more impactful. So taking the things that, I already do, you already do, and we're pairing them with some help, a little backup, I'll say. All right. So again, any takeaways, your biggest takeaway from this evening? While y'all are putting that down, I'm going to go ahead and drop the link to our bio link so you can go ahead and register for the webinar. Okay. So someone said lots of good discussion and strategies. My biggest takeaway is the tone setting. Yeah. So even thinking about it, parents, like when your child, one of those first times they hurt themselves, right? And maybe you've had some more wise people around you to say, don't act up, right? Don't, because if the child hurts themselves, the first thing they do is turn to you. They're going to catch their cues and their signals from you, right? And if you're like, oh my goodness, what am I? And you're just very worked up, then that's when the child cries. Because at first, guess what? Your child didn't cry at first. It was more of a stunned thing, like, okay, well, what's happening? What's going on? But they're catching their cues from you. So same kind of thing in the classroom. They're catching their cues. We set the tone. Parents, same thing at the table. If you're stressed and frustrated working on this problem, it's going to be a hectic situation on this homework, right? There's going to be the memes about you. If Johnny had 5 apples, we don't want to do that though. We don't want that to be us. Let the students know you are human, that you make mistakes. Also, that will remove some of their anxiety. That takes pressure off of them to be perfect. Indeed, especially the more and more pressure in, like I call it an obsession, right? The more we're taking off of, is the question right? We're backing up from that. Like, what is your process? How did you get there? I promise y'all, sometimes I really didn't care if the answer was right. Tell me how you got there. Because actually, while they're explaining, we'll figure out if the answer's right along the way. Right? So the tone setting is the SEL component linked to the math. Yeah, one big piece. It sure is. Definitely is. All right, you all. Well, thank you so much for y'all sharing and chiming in and good conversation this evening. And I will see you all next week. All right. Bye-bye.